Hello and welcome back. Congratulations on making this far. I believe you now have a solid foundation to grasp the core concepts of this course. In the upcoming videos, we will examine code snippets and learn the specific techniques needed to create a computer virus, which differ from regular software development. First, I want to walk you through the steps and considerations crucial for building a virus. A virus is essentially normal code that runs on your CPU. Here is a typical build process for normal software. You write code in a high-level language like C++. The compiler generates assembler files with a .s extension, which looks like something shown at the bottom left. You can also code directly in assembly when needed. Some people write highly optimized code for viruses to gain precise control over specific functions, and we will cover some of that later in the course. These assembler files are further compiled into object files, which are binary files containing raw CPU instructions. When you inspect these files, you will see a series of numbers that CPUs can directly interpret. Next, these object files are linked together into a single binary. The linker combines everything and resolves addresses, allowing functions from one object file to be usable by code in another. As discussed in the previous video, what happens before main runs? The C runtime CRT0 is linked by default at this stage. Elf sections are also formed based on a linker script that describes the layout of the executable file. Although most people don't think about this unless working with embedded systems, our linker provides a default linker script that works for most cases. After this process, we'll have a ready-to-run executable. However, the process changes slightly when writing a virus. Virus code cannot dynamically link to external libraries because it lacks the ability to find them at runtime. Therefore, our virus must be fully self-contained or statically linked. Since a virus typically runs before the host it infects, we don't want to execute the C runtime startup code twice. We need to provide our own startup and cleanup code, such as copying and restoring registers to their original states before running the infected host. We want to make it appear as if nothing has happened. We will tell the linker to use our own version of the startup file and disable the default one with --no startup files. Additionally, we need to provide a customized linker file to purposefully arrange sections in the desired order. Typically, we tell the linker to place all executable code of the virus in consecutive blocks, allowing it to be extracted as a whole binary blob. This extracted virus code can then be injected into other binaries. In essence, building virus code is a variation of building normal software with certain restrictions and customized building blocks. Don't worry about it if it's the first time you see behind-the-scenes actions for compiling software and it might sound overwhelming. We will examine these steps one by one in the following videos.